Hello everyone, welcome back. And in the previous video, we talked about the dividend discount model. We already showed that theoretically, if we use the dividend discount model to evaluate a stock, we need to discount all the future dividend payments. And if we assume that the firm is going to lose forever, theoretically, we need to discount infinite number of dividend payments in the future back to the current moment. And in practice, however, it's really not possible for us to discount infinite number of dividends back to the current moment. So in practice, there are something that we can do to deal with this issue. First, we showed that if we can make some estimation about the future, if we assume that we're going to hold the stock only for a finite period of time, and if we can make an estimation about the future dividend during this period, and we can estimate the terminal stock price at the end of this holding period, we can simplify the dividend discount model, and we can identify all the future cash flows, and we can discount the finite number of cash flows back to the current moment to get the theoretical value of the stock. And here in this video, I'm going to show you another practice in the industry usually we can do is that if we cannot make any estimation about the future, if we do not know about the future holding period, we don't know how long we're going to hold the stock, we cannot make any estimation about the terminal stock price, still we can make use of the dividend discount model, and we do not have to really discount the infinite number of dividend payments because that's not doable. Here we are going to make an additional assumption about the future dividend payments so that we can make things work. Usually when a firm pays dividend, the firm is relatively stable and mature. So it's relatively reasonable for us to believe that a firm that pays dividend is finally going to be able to grow sustainably. So here we are going to assume that the dividend is going to grow forever, and it's going to grow at a constant rate, relatively stable, relatively sustainable in the long run. So if the dividend is going to grow forever at a constant rate G, and we are going to identify the future dividend payment on the timeline. Suppose right now is time 0, and suppose the current dividend payment is D0. That's the most current dividend payment. Because the dividend is going to grow at a constant rate G for the long run. So in the next year, the dividend payment will be D1, which equals D0 times 1 plus the growth rate G, right? And similarly, in 2 years, the dividend payment will be D2, which equals the D1 growing at the growth rate G again. So it will be D0 times 1 plus G squared, right? Of course, we can identify the dividend payment for the 3rd year, dividend payment for the 4th year, and so on and so forth. So when we are discounting all the dividend payments in the future back to current moment, we're going to get this. Pay attention, we're going to start again from the 1st year dividend. We do not start from the most current dividend, D0, because this dividend was already paid. It will not contribute to the current value of the stock. The current value of the stock is only depending on the future dividend payment, right? So we start from the first dividend payment, which equals D0 times 1 plus G. So the present value of the first dividend payment is going to be D0 times 1 plus G, that's the D1, the first year dividend, divided by 1 plus the cost of equity, which is the discount rate, for 1 year. All right, and similarly, the second dividend payment D2, we discount that back to the current moment. The present value of D2 equals D2, D0 times 1 plus G squared, divided by 1 plus the cost of equity squared. And we discount the third dividend and the fourth dividend, and so on and so forth. Theoretically, we still need to discount the infinite number of dividend payments in the future back to the current moment. However, the good thing is, because the dividend payment is following a pattern, it is growing at a constant rate G. So this whole thing, okay, discounting infinite number of dividend back to the current moment, will be simplified to a simple term, which equals either D0 times 1 plus G over the cost of equity minus G, or just D1 over cost of equity minus G. Because of this special assumption we make, which is the dividend is growing at a constant rate G, the dividend discount model can be simplified mathematically to just one ratio, where the numerator is the first year dividend and the denominator is the difference between the cost of equity, the discount rate, and the growth rate of dividend G. So this model, this equation, this formula, where we assume that the dividend is growing at a constant rate G, is called the Gordon growth model. It's a special case of the dividend discount model, where we assume that the dividend is growing at a constant rate G. And the dividend discount model, the very, very long formula, is going to be able to shrink to a very simple short term, which equals the first year dividend over RE minus G. With this relatively reasonable assumption, we are able to solve this issue of infinite number of dividends we need to discount. We can just rely on the simple formula of Gordon growth model and calculate the theoretical value of the stock very, very quickly. By using the Gordon growth model formula, we are equivalently discounting infinite number of dividends in the future back to the current moment. So still, we are using the dividend discount model. We are using the very, very basic logic of a discounted cash flow model. And here, usually in order to forecast the growth rate of dividend G, usually we rely on this relationship. The long-term growth rate of dividend G equals the long-term return on equity, ROE, times B. The B here is the earnings retention rate, or the plowback ratio of a firm. In other words, B measures how much money, what is the percentage of earnings, is kept inside the firm, not paid back to the shareholders as dividend. Suppose B equals 20%, meaning for every $1 profit made by this firm, the firm is going to keep 20 cents inside the firm for further investment, for further expansion of its business. 1 minus B, which is 80%, is going to be paid back to the shareholders as dividend. So for every $1 profit made by the firm, 80 cents is going to be paid back to the shareholders as dividend. So 1 minus B is also called the dividend payout ratio. We mentioned the payout ratio in the previous video. So B times the return on equity, usually we use this relationship to forecast the estimated growth rate, long-term growth rate of this dividend payments. Let's take a look at some examples so that you know the Gordon growth model is actually very, very powerful and can be applied for many different types of situations so that it can really simplify our life. The first example is about an analyst following Sonoco. And this analyst finds that this company has a dividend policy of recognizing sustainable increases in the level of earnings with increases in dividends, keeping the dividend payout ratio within a specific range. So this is to tell you that the dividend discount model may be a good choice to evaluate this stock because the dividend payout ratio is relatively stable. So as the earning increases, the dividend will also increase. So of course, here we are going to follow the dividend discount model. And we need to figure out if there is any special assumption here so that we need to apply any special version of dividend discount model. First, this company's recent quarterly dividend payment is 31 cents. Pay attention, this is quarterly dividend. And when we are using dividend discount model, when we are discounting future cash flows, future dividend payments back to the current moment, we do everything usually on an annual basis. We discount the first year dividend, discount the second year dividend, and so on and so forth. And the discount rate we are using is the annual required rate of return. So here, since we are told of the quarterly dividend, we need to convert it into an annual dividend. So the annual dividend will be 4 times 31 cents, which is 1.24. And also you need to be very, very sensitive that this is coming from the most recent quarterly dividend. So the 1.24 is also the most current, most recent annual dividend, which is D0. Okay, not D1. Next, a forecasted dividend growth rate in the long run is going to be 4%. This is to tell you the dividend is going to grow at a constant rate every year. So inside the dividend discount model, we need to go to Gordon growth model, the special case of dividend discount model, right? And finally, Sonoco has a beta of 0.95, equity risk premium 4.5%, and risk-free rate 3%. Okay, this is everything we need so that we can use CAPM model to estimate the discount rate for our Gordon growth model, the cost of equity. So this analyst believe that the Gordon growth model may be an appropriate model to evaluate the stock. This is exactly what we just concluded. So to summarize, most current annual dividend D0 1.24, growth rate G 4%, beta 0.95, equity risk premium we already mentioned previously. Equity risk premium measures the risk premium provided by the entire stock market, by the market portfolio, which means RM minus RF equals 4.5%, not just RM equals 4.5, okay? And the risk-free rate 3%. So first we need to calculate the cost of equity, the discount rate for our Gordon growth model. And the cost of equity, required rate of return equals risk-free return plus beta times equity risk premium. So 3% plus beta 0.95 times equity risk premium 4.5%. And this gives you 7.275% cost of equity. That is what the investors require to get from this equity investment. That is the cost of raising equity from the public for the firm. We have the discount rate and we have the growth rate, so that we have everything for our Gordon growth model. Theoretical price for Sonoco's price equals the first year dividend payment, which equals the current year dividend payment times 1 plus G over cost of equity minus G. So 1.24 times 1 plus 4% over 7.275% minus 4%. And this gives you a price of 39.38. So theoretically, Sonoco's price should be $39.38. That's its intrinsic value. If the current market price of the stock is $38.10, slightly below the theoretical value we just got from the Gordon growth model. So in the stock market, people pay less for the stock. So right now, slightly the market is undervaluing Sonoco's stock. Sonoco's stock is actually worth slightly more based on our valuation just now. So a better choice for you is to consider buying the stock and hold for the long term. So far, so good. So this is a relatively comprehensive example to show you how to use Gordon growth model to evaluate a stock. All right, especially you need to first use CAPM model to get the cost of equity as the discount rate for Gordon growth model if necessary. Two things you need to pay attention to. First, make sure that you can distinguish the current annual dividend payment with the first year annual dividend payment in the future. Okay, so D0, D1, you need to be able to distinguish them. And also, to use a Gordon growth model, we require the cost of equity to be higher than the growth rate. In other words, the dividend payment cannot grow too fast, faster than even the cost of equity. Okay, it's not doable, because if the cost of equity is lower than the dividend growth rate, that will cause the difference between them to be negative. So by using the Gordon growth model, you are going to get a negative price for the stock. So that is not practical. All right, so in order to use the Gordon growth model to evaluate a stock that is paying dividend, the stock is not able to grow too fast in terms of dividend payment. And usually it's also not very likely that the dividend payment can grow very, very fast. Next example, we have a stock takeover target. This company is managed by a team that insists on reinvesting 60% of its earnings in projects that provide a long-term ROE of 10%. Okay, so this sentence gives us some information. First, this firm would like to expand, okay? And it is considering some reinvestment projects. And this project is going to provide long-term ROE of 10% if the firm follows this strategy, follows this path. For all the earnings the firm is going to generate, the firm is going to reinvest 60%. So 60% of all the earnings generated by the firm is going to be kept inside the firm for further investments. So 60% is the retention rate, is the B over here. In other words, 40% of the earnings will be distributed back to the shareholders as dividend payment. And here, the required rate of return for the firm stock is 15%. So RE is 15%. And the firm's year-end dividend will be $2 per share. Okay, so from this information, we will know that D1 is going to be $2. Okay, at the end of the next year. This $2 dividend is based on the earnings of $5 per share. So based on the retention rate 60%, we already know that 40% will be paid out as dividend. So 40% of the $5 earning is $2 dividend. Okay, so this is consistent with what we just mentioned. So the question is, what is the stock's intrinsic price? At what price the stock should be sold? So definitely we are going to use Gordon growth model because definitely this stock's dividend is going to grow at a constant rate because we have the constant retention rate 60%, we have a long-term return on equity 10%. So we know that the growth rate is going to be 10% ROE times 60% retention rate, which is 6%. The dividend is going to grow at 6% every year in the long run. And so according to Gordon growth model, the price should be the first year dividend over RE minus G, which is $2 dividend from each share divided by 15% cost of equity minus 6% growth rate. So this gives us $22.22. So this gives us an example in which we need to forecast first the growth rate of the dividend payment. Okay, let's take a look at this example. Here we have a stock which is a preferred stock. And we know that a preferred stock has no voting right, not like common stock. Preferred stock do not provide voting rights to the shareholders. However, preferred stock does give shareholders the priority to get money back if the firm is liquidated. When the firm is liquidated, first it's the bondholders to get the money back because it's the obligation for the firm to repay the money to the bondholders. So whenever the firm has enough money, bondholders get money first. And after the bondholders, after the debt obligations are fulfilled, it's the preferred stockholders' turn to get their investment money back. And also, preferred stock does give another priority to the shareholders. Preferred stockholders are going to get fixed amount of dividend payment every year, and this dividend is guaranteed. Not like common stocks. Common stockholders may not necessarily get dividend payment. It's the management team's call to decide whether or not to pay dividend to the common stockholders, but preferred stockholders always get dividend, and it's a fixed amount. This preferred stock pays 4% of its par value as dividend. Usually, when you see a preferred stock, usually you will see a percentage in its name, and this percentage tells you how much preferred stock dividend you can get if you invest in it. And this percentage is based on the preferred stock's par value. A preferred stock does have a par value, and this par value is used to calculate the dividend. And this stock has a par value of $25 per share, and it pays 4% of its par value as preferred stock dividend. So every single share pays 4% times $25, which equals $1 annually as dividend payments. So this dividend payment is going to be constant forever. It's not going to grow and it's not going to decrease. So it's always $1 per share every single year. And the required rate of return on this stock is 5.5%. So can we use the dividend discount model to evaluate this stock? This stock does pay dividend. We are going to use Gordon growth model again. Okay, even though that the stock dividend is not growing at all. But the Gordon growth model does not say that the dividend must increase over time. It only says the dividend is growing at a constant rate G. The G can be positive, can be zero, can be negative. So if the dividend is constant over time, it's not going to grow like a preferred stock, G is zero. We can still use Gordon growth model. Gordon growth model says stock price should equal the most current dividend times 1 plus the growth rate G over the cost of equity minus growth rate G, or equals the first year dividend divided by cost of equity minus growth rate G. Since here G is 0, meaning G is 0 here, G is 0 here, the theoretical price for a stock, either a preferred stock or a stock that is not growing in dividend, equals the most current dividend divided by cost of equity, or the first year dividend divided by cost of equity. Okay, it doesn't matter which dividend you use because the dividend does not grow at all. It's always the same. D0 equals D1. So here, $1 is the annual dividend payment, cost of equity 5.5%. The theoretical price for this preferred stock is $18.18. So you see that Gordon growth model can be used to evaluate a preferred stock or a stock with constant dividend payments. Actually, if you still remember when you were learning the time value of money, you must have learned about the perpetuity. If you get a constant cash flow periodically for infinite number of periods, time 0, in the first period you get D, in the second period you get another D, in the third period you get a third D, so on and so forth, for infinite number of periods. You get constant cash inflow. So if you would like to calculate the present value of all the constant future cash inflows, you discount the first D, you discount the second D, you discount the third D. If you discount all the D's in the future back to the current moment, the total present value must be D over the discount rate. Present value of a perpetuity equals exactly the constant cash flow each period over the discount rate. That's very simple, and this is consistent with our Gordon growth model when G is 0. So you see that the Gordon growth model is very, very powerful and it totally makes sense. Finally, as we mentioned, Gordon growth model does not say that the dividend must increase. The dividend can also decrease as long as it is changing at a constant rate G. Here we have a stock that is going to pay a $4.25 dividend next year. So the D1 is $4.25. It is estimated that the dividend is going to decline forever at a growth rate of 4%. So here, growth rate G equals not 4% anymore, but negative 4%, showing the dividend is going to decrease. And the required rate of return is 9%. What is the theoretical value for this stock? using Gordon growth model, we have D1 over cost of equity minus growth rate G. Here D1 is $4.25. Cost of equity is 9%. And the growth rate G is negative 4%. So we have 4.25 over 13%. So the theoretical price for this Afton mines should be $32.69. You can use your calculator to verify that. So that's Gordon growth model, and because we can make a reasonable assumption that the dividend is going to change at a stable growth rate, it's either a positive growth rate or zero growth rate or negative growth rate, as long as it's going to change sustainably, consistently over the long run, following a pattern, we can use the Gordon growth model, a special case of the dividend discount model, to evaluate such a stock. So make sure that you practice again and again the examples mentioned in our slides, as well as the examples in the study guides. Okay, so this part regarding the valuation models is all about practice, even though that it's about math, it's about numbers, but it's doable, and you do not have to define yourself as a number person, as a math person. Everybody should be able to do that as long as you spend enough time and really work on those practice questions. Okay, let me know if you have any questions.